look at our lower level plan, there is this diagonal hatch that goes through the foundation wall, and that's kind of typical when it's showing a load-bearing wall condition, or when we're trying to differentiate materials, like where we have a foundation wall that might also have an interior footing on it. It just helps to make that more legible in terms of the fact that there are two different things going on there. So how do we go about creating that diagonal hatch? This is our 28 by 44 foot footprint for the house, 8-inch foundation wall, and I'm going to ignore the fact that there's some holes in it for the doors right now, just to make it simple. To hatch, what you do is this icon in the upper left-hand corner is the hatch function. And what I am going to do is select that hatch function, and then it brings up all sorts of different options for what's going to happen. The first of those is two options. One is to pick points or to select objects to hatch. In this case, I'm going to go ahead and use this first one, pick points. But before I do that, I'm actually going to select the type of hatch that I want to go in there. And this drop-down menu has a billion different options for hatches. Most of them we do not use. There are just a very few that we end up using. So if I go back up to the first row, this first option, the ANSI 31 hatch pattern, that's what we will use for the foundation wall. So that's easy to get to and find. So I'm going to select that pattern. I'm going to go to pick points, and then I'm just going to pick inside. I'm going to go ahead and pick inside my foundation wall and select hatch. Now if I zoom in, I can see, oh yeah, there's the diagonal pattern is there, but it's just so small that it's not legible. So what I can do now is go to CH, change prop. There are two things I can do. I can just select on the hatch itself, and I can get back to this menu that allows me to change the scale of the hatch. So right now it's set at 1. I'm going to go ahead and just show you what it looks like when it's set at 12. Hatch pattern got bigger, right? What I'm going to do is actually adjust that to 24. And that hatch pattern for the foundation wall is pretty close to what we want for the foundation. So that's how you go about setting up the foundation wall hatch. Everybody got that? Really pretty simple process. Eric, got it?
Yeah,
Okay.
very simple. Thank you.
Yeah, absolutely. Okay, so let's then go on to how it is that we go about creating our section drawings. So what I have up here is where I left off when I was showing you how to start with the plan drawings. What I'm going to do is go back to my layer list, and I'm going to select guidelines, because I'm going to end up drawing some guidelines again to begin with, just like we did with our plan drawings. The other thing I'm going to do here is I'm going to copy the main level floor plan that I started with. Yours is much more developed than mine. But I'm going to copy that main level floor plan, and I'm going to use that to help me get things in the right locations. I'm not going to start from scratch and measure as I start my section drawing. I'm going to use my floor plan drawing to help me create my section drawings. But before I can start using this floor plan, it's not oriented in the right way. If I go back to my set of drawings here, if I take a look at the section drawings, maybe I should back up just 1 second and say, there are 2 section drawings in your packet that you will end up creating. there is sheet A401, which has a section through the garage on the basement level, the living room and kitchen area, to the bedroom on the upper floor level. This, section A401, is where you want to start, because it is the simpler of the two. And once you have this section drawn, you will have most of the section drawn that you'll need to use for A402, right? So if you draw this first, you can literally copy it and then modify it as you start to draw section A402. So we're gonna start with A401 today. That's where we'll begin. When we look at this drawing, again, it's cut through the living room and the kitchen and the garage and the bedroom. And if I go back to my AutoCAD drawing, if I were to cut through this way so that I'm drawing the drawings so that I can see it as it actually is, the plan isn't oriented in the right way. So to start with, I'm just gonna go ahead and rotate my plan so that it is oriented the right way. So here's my living room, here's my kitchen, and if I were to cut kind of an imaginary line right through this space, that's really where that first section is cut. Garage in the basement, living room and kitchen on the main level, and then my bedroom is stacking right above this area on my upper level. So to begin with again, what I am going to do is draw a series of guidelines that are going to help me locate where my foundation wall is, the face of my foundation wall, outside face, where the outside face of framing is, and I can figure out from there where next from there, I'll go ahead and show where my floor levels are with guidelines. And once I have all of those datums in place, my vertical guidelines for the wall locations, my horizontal guidelines for the floor levels, I can start to create my section drawing. So just like we did with the floor plan, lay out guidelines that locate structure first. That's where we begin. So let me get started. What I'm gonna do is just zoom out a little bit. And I'm gonna draw my first guideline from really the guideline where my exterior wall was in the plan drawing. From this corner, I'm going to draw that guideline down. And from this corner, I'm going to draw that guideline down. And I'm just gonna move them so that I can see them separately from the floor plan drawing above, okay? So why measure when you've already drawn the floor plan accurately, and we can just essentially use that as our template, as our background for the vertical guidelines here. Right, now what I'd like to do is to start to create horizontal guidelines that will establish where my floor levels are. And what I'm going to do first is start with the main floor. There's a guideline for the main floor level, and if I go back to my section drawing in the packet, we have a hypothetical, a theoretical elevation of plus 100 feet for the top of sheathing at the main floor level. Everybody see that? If I start from there, and if I start working up, my next datum elevation is where the trusses bear on the exterior wall that provide our roof structure and our second floor level. And the difference in height is we go from 100 feet to 109 feet, 1 1/8 inch, right? 9 foot 1 1/8 inch higher than my main floor level. So going back to my AutoCAD drawing, offset 9 feet, 1 foot 1 1/8 inch up, and that's where the truss bearing elevation is, okay? Now if I go back to my handout, I can see that I have another elevation to work with here. It's the top of the floor sheathing for the upper level, and that datum elevation is 110 feet, 8 1/4 inches. Or, another way to think about it is it's 10 feet, 8 1/4 inches above my main level top of sheathing. Okay, everybody still with me? So going back to my drawing, offset 10 feet, 8 1/4 inches from my main floor level, and voila, there is my top of sheathing for the upper floor level. I'm just gonna keep going vertically now to the next datum elevation, and that one is here at the underside of my roof truss, what would be the ceiling, of the upper floor level. And that datum elevation happens to be plus 118 feet, 9 3/8 inches, or 18 feet, 9 3/8 inches above my main level top of sheathing. So I'm gonna go ahead and offset 18, 9 3/8 from my main level top of sheathing again. And there I have all of the datum elevations for, from the main level on up, okay? So everybody with me so far? Okay. What I'm going to do now is actually start to give myself some structure here. So I'm going to switch from the guidelines. I've got enough to start anyway. And we will, the other thing I should cover with you here is we're going to be using a different set of layers for this drawing compared to what you used for your floor plan drawings. So with the floor plan drawings, everybody was using this group of layers primarily under the floor plan section of our layer list. What we're going to use for this next drawing, and actually for the elevations as well, is we'll use the elevations as sections area of the layer list. So it's just a few. Go ahead and actually create all of those layers right at the start, because we will use all of them. Get them in there, and then we can start drawing with them right away. So what I'm going to do is, back to my AutoCAD drawing. I don't know that I have all those layers created. We'll use A elevation fine, and the reason I'm using A elevation fine is that it is, going back to my layer list again, it is a red pen. It is the very fine pen with a pen width of 0.09 millimeters. And if we compare that A elevation fine, we want to use A elevation fine. It's the red pen, fine pen, 0.13 millimeters in width. That happens to match the appearance of my A wall framing pen, right? So when I draw the structure in the section drawing, my walls, it's going to look like the walls that I drew in my floor plan. The pen widths will be the same. When it comes to drawing the outside finished face of my exterior walls in the section drawing, let's go and take a look at that. I'm going to use this layer down here, A elevation wide, which happens to be that blue cyan color, and that happens to have a pen width of 0.50 millimeters. Let's go up to our floor plan layer list, and if you take a look at the A- wall layer, our outside finished face for our walls, it is exactly the same, cyan, and it is 0.05 millimeters in pen width. So when you take a look at the finished product, your CAD drawings, they will look an awful lot like your floor plan drawings in terms of the appearance of the colors of different layers in your drawings. The structure is going to tend to be on a red color layer, whether it's walls or floor structure. Your outside finish face is going to tend to be on that cyan, that blue color. Okay, so that's going to make it easy to remember which layer do I want to use from this list when I'm drawing my section drawings. It's just going to look a lot like what we see in our floor plan drawings. So, who have I lost at this point?
For Trace's bus, we use section, A section,
You can do that too, yeah, yep.
It's the same.
It's, yeah, exactly, it corresponds, you can use the A section layers too. Yep, you can use those, they're the same corresponding colors, same pendants. Instead of it being an A elevation, it's just an A section, okay? I didn't realize that was something she had you guys do.
We're talking about her hard copy sheet?
Yeah,
Okay.
I've got to update mine, just to get it synced with yours. Okay, so everybody's with me so far, that's awesome. All right, so now that we've talked about the layers, let's go back to our AutoCAD drawing. And at this point, what I'm gonna do is start drawing my exterior walls, starting with, not the finished face, starting with the framing, just like we did with the floor plans. So I'm gonna get in here, get to my A elevation fine layer, and I'm gonna draw a line from my main floor datum elevation up to the datum elevation for my upper level. And I'm just gonna leave that as kind of a temporary stopping point. Okay, we're gonna modify that coming up here in a little bit. So that is the outside face of my framing for the exterior walls. Also the outside face of the truss for my upper floor level right in this area. Okay, so going back to my AutoCAD drawing, I'm gonna give that a thickness of 3.5 inches because my exterior walls are 2x4 frame. Okay. So I've drawn the framing for my exterior wall on that side of the section drawing. From here, what I'm going to do is offset my outside face of framing 1.5 inches, because that is, after all, the thickness of that layer of finished face outside. And I'm going to offset the inside face of framing 1/2 inch. And now I have the location for my outside finished face, exterior and interior side of the wall. And I'm going to go ahead and get that on the A section heavy layer, and I don't have that created, so I'm just going to use this one for now. And this is what my wall in the section is going to look like. Okay. So from here, I could go ahead and do the entire process on the other side, just to draw all those pieces. But because I'm a lazy drafter, what I'm gonna do is just draw a temporary construction line down here between my guidelines, just a throwaway construction line. And I'm going to mirror by using MI as the keystroke command. I'm gonna mirror those lines that I just drew. Let's have midpoint selected. And there they are. So why waste time drawing them again when you can just use one command to mirror them? So the next thing that I'm going to do here is I'm going to start drawing my truss for the upper floor level. Again, I'm drawing structure first. So my next datum line up from my main floor top of sheathing was the bearing for the truss for the upper floor level, or my top plate for the exterior wall. So I am going to, at this point, go ahead and draw a line, and that is the underside of my truss for the upper floor level. I can now offset that line for the thickness of my gypsum board on the ceiling of the main floor level. And what is that thickness again for ceilings? 5/8. Thank you. I'm going to use match properties and just get my ceiling gypsum board on the same layer as wall gypsum board. And using my favorite command, chamfer. We'll go ahead and just clean up those corners. So now I have the inside finish face and the ceiling finish face for my main floor level done. I'm gonna go back to the structure because the next thing that I want to do is to figure out where the bottom chord is for my truss. If you remember, the next datum elevation up is for the top of sheathing. I actually want to figure out where my truss chord is because that is different from where my top of sheathing will be. Okay, so I'm gonna actually go back to the handout here at this point and dig for a little bit of information. Because in our handout, what it describes is, and I need to zoom in here, that our roof structure up here at the very top, it describes what that truss is. But first of all, it says, well, my roof sheathing is 5/8 inch roof sheathing with roof clips, and it's installed over engineered prefabricated trusses, and this happens to be an attic truss or a storage truss. And we have 1 1/8 inch thick OSB floor sheathing over an 18-inch deep truss bottom chord. That's what I want to look for, is my bottom chord is 18 inches deep. So I'm gonna go back to my drawing and offset 18 inches from the bottom side of the bottom chord to the top side of the bottom chord. And there's the bottom chord of my truss, right? And from there, again, up to my datum elevation, that's the thickness of the floor sheathing for my upper level. And
Are
if
you on the, is that the main floor?
that's the second floor level.
Oh, so you're drawing on this.
Yep, I'm starting on the second floor level, yeah. And then we'll start on the main floor level and work down. But going back to the description we have in the handout, I want to go back to this 1 1/8 inch OSB floor sheathing, okay? That's not standard, is it? Standard floor sheathing is 3/4 of an inch, and we've talked about that in 1020. Why aren't we using 3/4 of an inch floor sheathing here, if that's the standard stuff? Why are we using 1 1/8 inch instead? Any thoughts? Maybe? Okay, what about our truss spacing?
The spans are
Spans are bigger, yeah. Because most floor framing, we're at 16 inches on center or less. Here, because these are roof trusses, they're spaced at 2 feet on center. So 3/4 inch thick floor sheathing can't span, it's not rated to span 2 feet. It's going to be spongy, and it's not going to have the strength that we need for that span. So we actually have to increase the thickness of our floor sheathing beyond 3/4 of an inch to make it work. And in this case, we're using 1 1/8 inch OSB, another standard OSB thickness for our upper level top of sheathing. Okay, so I don't want to lose anybody in that little detail. We are using a different thickness for our exterior floor sheathing here, intentionally, with 1 1/8 inch OSB. Okay, so let me now go back to my section drawing, and I'm gonna start from our main floor level, and I'm gonna start working down to get our structure for the main floor, between the living room area and the garage area. Going back to my handout, again, it tells me that my main level floor structure is comprised of 1 1/8 inch thickness warm board radiant sheathing with hydronic radiant heating system, or 1 1/8 inch OSB floor sheathing. So that's another reason where this 1 1/8 inch thickness has come in. In this particular case, this house, as it's designed, we're going to have some rooms that have radiant floor heating in them. And there's a product that we're seeing here called Warm Board Radiant Sheathing that is a special type of structural floor sheathing. It is structural floor sheathing that has the grooves, and we're gonna see this later in the semester in 1020, but it has grooves in the top of it that we can put the tubing for radiant floor heating systems right in our floor sheathing. It's a brilliant product, it's a great product, it's just really expensive. So we're going to use that for our structural floor sheathing, but also it's going to allow us to have radiant floor heating systems. Where we don't have radiant floors on the main level, we're just gonna infill those areas with 1 1/8 inch standard OSB so that the thicknesses are equal and they time out with one another, okay? So that's a long explanation to justify what I'll do next, and that is, I'm gonna go ahead and draw another line from my outside face of framing to my outside face of framing, and that line is the top of that warm board or OSB 1 1/8 inch thickness floor sheathing, okay? So I'll offset that line 1 1/8 inch, and there's the underside of my floor sheathing. Going back to the handout again, just to continue reading the description of our main floor structure, it tells me a little further down that all of this is installed over an 18-inch deep truss that's spaced 16 inches on center. So I'll go back to my drawing and offset from the underside of my floor sheathing 18 inches. And there is the underside of my truss for the main floor level. And I'm just gonna kind of stop there now because that gets into what happens when we transition to the foundation wall. I'm gonna leave that for today. I'm not gonna get into that. But what I would like to do now is go back and start working from our upper level and figure out our roof structure so that you can get the roof structure drawn properly. So before I do that, any questions? Okay, have I lost anybody completely yet? Getting there? Okay. All right, so I'm gonna start on the roof structure. And what I'm going to do is go back to my handout, and I'm going to see that, okay, this roof structure again is this big attic storage truss. And I can see that the truss has what's called the truss heel. Over here, there's a dimension of 3 feet 9.5 inches, and that is from my truss bearing datum elevation, this one down here, up to the underside of the roof sheathing at this point. That's what the truss heel is again, if you remember from our discussion a couple of weeks ago in 1020 when we talked about roof structure. So I'm going to use that 3 foot 9.5 inch dimension to figure out my work point so I can start drawing the actual truss itself. So I'm going to go back to my drawing, and I'm going to offset feet 9.5 inches. From bottom of my truss up to that work point, and that happens to be right here. Okay, that is where the top of my top chord, or if you want to think about it this way, that's where the underside of my roof sheathing is going to be, directly above the outside face of framing. Everybody still with me? So what I'm going to do next is I am going to start drawing the slope for my roof structure from that work point. And the way I do that is I'm going to enter L for line. I'm going to pick that work point right here. And now you may not have used this string of commands yet, and I'll show it to you a couple of times so that you see it. But it's a way of drawing a line that has a specific horizontal distance and a specific vertical distance, and it is a miracle for drawing roof slopes. So from that end point, I am now going to press the shift key and 2, which brings up at, and now I'm going to enter 12 feet, comma, 10 feet. And voila, it has drawn a 10-12 roof pitch for me. Oops, I'm sorry, we actually have a 12-12 pitch on this one. So I get to show it to you a second time, how about that?
Wait, you hit the shift key and 2?
Okay, let me show it to you again. Okay, I'm going to start from that work point, the end of the line, and I've given my base point. Now I'm going to enter shift 2, which gives me the at symbol. I'm going to enter 12 feet, comma, 12 feet. And there's my 12-12 roof pitch, drawn absolutely perfectly accurately right from there. Okay. Now I'm going to go ahead and just get rid of this construction line that I used to figure out where that work point is. I don't want it around anymore. It's just going to get in the way. So I'm going to start drawing now from the top of my truss, this first line that I drew at a 12-12 pitch, drawing the inside of the truss, the rest of the truss from there. So going back to the handout again, where it talks about the roof structure, it says that all of the web members and the top and the top chord of the truss are 2x6s, okay? I'm gonna go back to my drawing, and I'm gonna offset from the top of my top chord 5.5 inches, because that's the dimension of a 2x6. I'm gonna offset that down. Okay, everybody still with me? Next thing that I'm gonna do is I'm gonna go back actually to my exterior walls, and I'm gonna trim a little bit. And I'm going to draw the outside of my truss from the outside face of framing up to that corner, that work point, where my top chord is. And I'm going to offset that line 5.5 inches as well, because all of the web members, again, are 2x6s. So at this point, I'm going to use chamfer, and I'm going to clean up where the top chord meets the heel of the truss here, and I'm going to clean up where the heel of the truss meets the bottom chord. And that's where my roof truss starts. And going back to my drawing, yep, that's sure what it looks like. Okay. Let me now go ahead and get the rest of this truss drawn, and we'll draw it on one side, and we'll mirror it to the other side, so we only draw it once, and hopefully we draw it accurately at one time. So going back to my packet, I don't really have any helpful information on this section drawing that would tell me where this vertical wall is in the bedroom, or where that web of the truss is, and that's really what I need to figure out next here. So I have to go back to my floor plan drawings and figure out, wow, is there anything there that's gonna tell me what that is, that's gonna help me out? And there actually is. This wall in the bedroom happens to also be where that web member is in my truss. And there's a dimension on the floor plan drawing here of 14 feet from face of framing for that wall to face of framing for this wall. Or another way to think about it is the center line in this room is right down the middle, and I have 7 feet from the center line of that room to the wall on either side. Is everybody still with me? Because if I think about it that way, what I can do is go back to my drawing, and this construction line that I started with initially, I'm gonna draw a vertical line. That's the central line of my room on the upper level, the center line of the house too, by the way. And I'm going to offset that line 7 feet in each direction. And I'll only actually do it in one direction, because I'm gonna mirror the truss again. So that's the face of that web member, face of the wall in the bedroom. And I want to offset that 5.5 inches to the outside because my web members are all 2x6s again. Now I'm gonna do a little bit of trimming so that it looks as it should in the drawing, and I'm gonna start by trimming it to the underside of my top chord. And I'm going to trim that line to the top of my bottom chord. And then I'm going to go ahead and trim the lines out between the inside and the outside face of that wall. And that's what my drawing for the section looks like. Here is that wall in the bedroom. Now, I can go ahead from here and figure out where this diagonal web member is. Piece of cake, because what I'm actually gonna do is just start with this corner where my vertical web member hits the bottom chord of the truss. And I'm gonna draw that line perpendicular to my top chord. Oops, that wasn't perpendicular. That was midpoint. Selected. It's not. So there's perpendicular. And I'm going to offset that line 5.5 inches as well. So all of my web members are 2x6s. Now if I go ahead and clean up my corner and trim up here, that is exactly what the truss looks like for half of the roof. Okay? Any questions at where we're at right now? Okay, doing okay? So I want to go one step further here in drawing my roof truss before I mirror it to the other side and then start really making it look like the drawing that we're working with. If I go back to my section drawing in the handout, we see that the top chord of the truss actually extends here. It goes beyond the face of the exterior wall, and the tail of the truss is 1 feet 11 inches to the end of the truss from where the outside face of framing is from my exterior wall. Everybody see that dimension? So I'm going to go ahead, go back to my drawing, and I am going to extend 1 foot 11 inches to the outside face of my exterior wall or truss, and that's where the tail of my truss ends. And I'm just going to extend my top chord lines to meet that, and then go ahead and do a bunch of trimming. Trimming here as well. There's my truss that I have drawn. So at this point, the truss is drawn. But let's go ahead and let's actually show what's above the truss as well on this side so that we can use that to mirror over to the other side. So on top of my truss, I have roof sheathing. And if you remember from the description in the handout, that roof sheathing is 5/8 of an inch in thickness, right? On top of my roof sheathing, I'm just going to offset a line 1 inch, which is kind of the thickness of all the shingles and stuff that's gonna go on top of that. It's not a precise dimension. I don't really care. It's just an approximation. So I'm gonna finish up by drawing my sheathing and then my roofing material on top of the sheathing. And then I'll be ready to start mirroring things over. So going back to my drawing, offset 5/8 of an inch first from top of sheathing up. Offset 1 inch from my top of sheathing up, not 1 foot, 1 inch, and that's the top of my roofing material. So I'm going to go ahead, and because that's a finish face, I'm I'm going to put that on the A section wide layer. Okay, so I am at a great point here, because what I can do, I'm just gonna stretch this line down a little bit so you can see. I'm gonna go ahead and mirror what I've drawn on one side, and we're gonna make that first. Let me do this. I'm ready to mirror. So I'm gonna draw from that construction line, that's the middle of the room, the middle of the house, and there's my roof structure. And then I'll go ahead and just use chamfer, and we'll clean up all of these lines up above. We'll join that. Voila, we're almost done. The last little step that I'll do here, just to continue and show the rest of the room for the bedroom, is if you remember this next guideline, actually my last guideline, is the underside of the truss for the flat ceiling. So I'm going to go ahead and draw a line from that point over to that point, which is the underside of that flat member of the truss. It's a 2x6 again. So I'm gonna offset that 5.5 inches. And I will go ahead and trim there and there. And the next thing I can do is offset from my ceiling 5/8 of an inch. Offset for the walls, 1/2 inch. Before I do that, you know what I'm gonna do? I'm gonna go ahead and draw my floor sheathing. Get that in here. So that's from that point on my datum elevation to that point. That's the top of my floor sheathing. And now I can go ahead and offset for my gypsum board thickness here. And I'll use match properties again to get those on the right layer. And we'll clean up that intersection.
5/8 on the ceiling.
5/8 on the seam. Yep, exactly. We're almost done. Again, this is our structural floor sheathing that we have on top of our bottom cord of the truss, that 1 1/8 inch thickness. We have a thickness for our finished floor on top of that. And I'm just going to assume that our finished floor material is 3/4 of an inch in thickness. All right? So I'm gonna offset 3/4 of an inch from the top of my floor sheathing up, and that becomes the finish face for my floor. And I can then go ahead and chamfer the gypsum board at my wall to that. So we have couple more steps and we're almost there. I'm going to mirror my wall gypsum board from this side. Over to this side. And again, go ahead and I'll just use chamfer to clean up those corners.
How thick did you make the dimensions there?
3/4 of an inch. Yeah. And that's kind of, you know, it's a standard dimension. There's no real, you know, precise thickness because those floor finishes can vary. It could be wood, it could be carpet, it could be tile floor finish. I'm just kind of assuming and giving that a 3/4 inch thickness regardless of what it is. Okay, nothing magic about that one. So that's how you go about starting your section drawings for the bungalow project. And once you have this A401 sheet section drawn, that's your starting point for drawing A402. You just take what you've drawn and you change what you need to in that drawing to reflect what you see in A402. So, any questions? You have plenty of time with this assignment because it isn't due until what, March 18th or something like that?
See the break in there.
Yeah, spring break is in there. Yep. So you get to spend your spring break on your computer working on the section drawings. How about that?
That was my plan.
Yeah, yeehaw. Have a ball, guys.
Sounds like a party.
Yeah, yep. Okay, so that is, that's that for that.